Hi everybody. I have noticed that the topic of security has been raised more and more often recently. And if you visited the recent event dedicated to Go, you've probably noticed just how high on the priority list it was. In fact, security in DevOps is a major priority. This table shows the role of security in DevOps. Even before we start developing something, we agree that we will have some security, we will have to implement certain security measures and practices and so on and so forth. In fact, the right column is much larger, especially if your project is related to security. I'm not a security specialist, I'm a developer and I work in a bank, and I really care about making sure that my code is secure. But some time ago, I really asked myself this question: what does it mean for an application to be secure? And today, I'd like to consider together with you what security means for a developer. There are different approaches. If we're talking about applications that are launched in the cloud, microservices, or a small application, you can represent it the following way. For example, we have code, we have some data inside this application. There are dependencies on top of that, and then we may be launching our application in a container. The container runs on the platform, and the platform exists in the cloud. If we only focus on development, we don't care about the cloud, we don't care about the infrastructure or the platform. However, we do care about the dependencies, container, code, and data. Let's start with the basics. Data. If we talk about data, the most important thing that we should be aware of is passwords. Passwords need to be encrypted. Unfortunately, Facebook and many other companies forget to encrypt their passwords. So the question is, how do you do this? You can do it on the application side or on the server side. The simplest option is the best. We can make, for example, this request, and we get an encrypted password. We don't have to do anything code-wise, we don't have to create any additional algorithms. But what if we need to generate a password or generate a key, some random sequence? We have this library, math/rand, and this library allows you to generate random numbers. And if you have never done any random number generation, that's the first thing you may think of. But let me do it a slightly different way. Here is a code that I have here. I have generated a random sequence of 4 bytes. Then I launch this random generator again, and I have the same sequence of bytes. So what's wrong with this random generator? It's got this seed parameter, and perhaps if I change this seed, I get something more random than the previous thing. If we use a constant for the seed, then we're going to get the same random quote-unquote number. If we use time for the seed, because time changes, therefore the seed changes, therefore we get all the time we get a random sequence. Let's see. Let's hope that it works. Okay, this is my first sequence, random sequence. This is my second random sequence, and the third. Every time I generate a random sequence, it's really different. Cool? Well, not totally cool, because it's easy to predict. It's easy to predict the result of this random number generation. This is not a cryptographically secure way of generating the random number. The only thing we need to know to be able to predict this random sequence is just to know the time at which the random number is generated. Fortunately, we have cryptorand. This code generates cryptographically secure random number sequences because in this case we don't use this mathematically vulnerable way of generating random numbers. We use a operating system primitives and other seeds that are completely random and impossible to predict. See, we get random numbers all the time, and this sequence is impossible to predict. So this code is much more secure and much more suitable for random number generation. What else do we have? We have secrets, sensitive information such as database passwords or perhaps some API access keys or third-party service provider keys. And you know that it's not the best practice to keep those access keys directly in your code. But not everybody does this, and if you Google, you can find a lot of passwords that are stored as files. We know that that's not the best practice. So what do? We delete these passwords, but we also shouldn't forget about the need to delete the commit history, because these passwords can be easily mined from the history of commits. So, if you have found passwords and you decide to delete them, don't forget to also clean up the history of those commits. Okay, so suppose we know that the passwords should not be stored that way. We know that Kubernetes has some secrets. We want to learn whether or not these secrets are good for us in terms of improving the security of our code. First of all, we need to understand how these secrets are stored. We need to figure out who has access to what, and how do we transmit the secrets through these applications. Some of the secrets are stored as environment variables. We transmit them to the application through these environment variables. But the question you want to ask yourself, of course, is how secure it is. This is a snippet of code. We just launch a very simple app server in a container, and here's where we store our secure information that perhaps we will transmit somewhere later on, but not now. This is our Docker file. I have launched it. I have launched my container. But if I type in the terminal this command, for example, I just want to take a look at this file, prods nvrun, I see that my environment variable is stored here, and it's not at all encrypted. So, the bottom line is this way of storing your access keys is absolutely not secure. So, what's the solution? The solution is already there. It's called Vault. Many service providers provide their alternative solutions, and I know that many people out there prefer different solutions that they like. But if you prefer this way, you can be completely sure that it is secure. The next layer is the layer of code. Speaking about this layer overall, in light of security, the most popular story is that we may have some SQL injections or XSS attacks. For example, when we forget to validate user inputs, and that breaks down our application, the application makes an error and may even go down. That's a very common story. And what do we need to care here? First, we need to care about validated user inputs, and especially do we need to do so if this input comes from some third-party service. We need to make sure that the data is clean, is valid, but very often it happens that even if we created the service ourselves, sometimes the data may not come valid. and may even compromise the security of our applications. So you need to validate this data even if it's from your service. The next thing you need to remember about is diagnostic handlers. Profiling results can be reported using standard libraries such as net/HTTP. This library can be used to request the application for some diagnostic information such as memory use and routine use. What matters is to never show these reports to the user, because this opens a potential gateway for attackers. This may not be obvious at first, but in fact, you can change the prefixes slightly, and then you can use this as a potential backdoor into your system. So please do not expose this information to the user. So how do you protect yourself against these problems? GoSec linters do provide a certain level of protection against these kinds of attacks. Also, you need to make sure that you never use weak random number generators. For example, here, if you look at this code, the code assumes that we use this linter shows that the use of weak random number generator is a bigger security issue than the possibility of an SQL injection. If you were in the adjacent room before the lunch, you probably heard about Golang CI. Golang CI can launch multiple linters at the same time, so if you have not seen this presentation, I encourage you to review it later, because in fact, on top of those linters, you can find lots of other security tools that can increase the level of security of your application. So, again, another thing that I would like to mention to you is unprocessed, unhandled errors. So how do we validate user input? For example, we have implemented some algorithm and it seems to be working fine, but we can use the library called GoFuzz, which implements all sorts of fuzzy testing. They generate all sorts of different inputs. Some of them may break down your system and compromise it. So, if after fuzzy testing your application is fine, then you can be assured that in this respect, at least, your application is secure. What are the vulnerabilities in Go? 11 vulnerabilities were identified throughout 2018. Well, they were of different severity. But what I encourage you to do, what I strongly encourage you to do, is to review these security alerts and take them into account as you develop your code. But also, the third layer is the dependencies. Probably this is one of the favorite topics that gets talked a lot about. Dependencies are something that we don't own as developers. We cannot make sure that we don't know what's going to happen with the dependency tomorrow, what's in it, how many tests were used to ascertain its security, what tests, whether these tests were adequate or not. We don't know. We don't know how this library or that library is supported, whether or not it will be supported tomorrow. Another potential vector of attack are licenses. We very often ignore licenses, but sometimes they contain information which may be a potential vulnerability, which may create a potential vulnerability for your company. So, if you just click through the license without actually reading it, you expose yourself to a lot of potential risks. Another thing Another thing to remember are integrity and dependencies, because when we import the code, we lose sight of the fact that dependencies may depend on other dependencies, and so on. And immutability and updates. The standard way of distributing libraries is to post something on GitHub. The users download things from GitHub. We use semantic versioning. But of course, nobody prevents you from repushing, force pushing a new library. So if you use something that seems to be working in a stable fashion, it doesn't mean that tomorrow things are going to stay the same. So what you need to do, you need to create a checklist for working with dependencies. If you consider using a new library, you need to look at its description. You need to see whether the description is reasonable, whether the author created a reasonably good documentation with interesting and useful, informative use cases. If you were present at the previous presentation, you can also run this dependency through a linter, just to get some rough idea about how good is the quality of this library. Also, you can look at the issues and pull requests of this library. In other words, how often do the authors accept pull requests, how often do they report bugs, and how quickly do these iterations happen. All of these things are major factors in making the decision whether or not we should be using this library or not. The next is dependencies checklist, or how well tested this library is. It would be problematic to launch tests and monitor the coverage of a library if you don't know anything about it. But we want to be sure that the quality of the library we consider using is enough and is sufficient. And also, you can also include all sorts of new descriptions. You can use the linters, and thank God there are many different linters out there. Okay, we have checked one library, so what do we do then? We have to do the same, run through the same checklist for every single library. If we want to be completely sure that there is no malware installed in any dependency, we have to run every single dependency through the same checklist. We also have GoProxy. Hooray! GoProxy helps us handle some of the potential issues. For example, if GitHub is not available, GoProxy can be hosted inside of your company, and it will always be available to you. Regardless of GitHub and irrespective of any other sources, if the author decides to delete from the repository his or her project, it doesn't mean that we are in trouble. Another thing is immutability. With GitHub, we may have a force push, and our library cannot be guaranteed to be immutable. But if we use GoProxy, we can have this guarantee, which is good. If we want to be completely sure that nothing changes overnight without us knowing that. Even if there is force push, you can always have the right version of the library available to you at all times. Go modules are archives, zip archives, and if you compare, for example, how we download Go modules to our applications and how we clone our repositories to the local drive, it seems that it's in fact much faster to download the zips instead of using Go gets, which clones the entire repository and does some additional steps. We also have to think about integrating with some vulnerability databases and linters to be able to more or less automatically measure whether or not the library we want to use is good quality-wise, whether it's secure. Unfortunately, Go proxies don't do it that way. And the current ways of the current versions of GoProxy are quite limited in their functionality. But also, even if we use GoProxy, we have to understand how we structure a process around GoProxy. Because downloading all the modules to GoProxy is not going to give you anything good, because it does not guarantee you that the modules that you download are secure. So we have to decide whether we check everything that goes through GoProxy for security, or we do it in some other way, in some completely different way. But again, we cannot trust whatever we download from the internet. And I can stop here. Okay, we have code, we can compile it, we have compiled binaries which we can put into the container. And as a rule, there are two ways for compiling a binary. We can compile it for continuous integration, for continuous delivery, and put it into the container, or we can choose multi-stage containers. In the first case, we will have to use the whole tool chain, including the Go compiler, to run all the binaries. In the second case, we don't need it, because our file will have a lot of from structures. And this zero stage will be prepared for the binary. We just compile the code we need. We recreate the users, because we don't want to launch the application, the containerized application, as root. So we prepare everything we need, and as a result of this stage, we get a binary. And at stage 2, we can copy it to anywhere we want. We can, for example, copy the certificates for working with third-party resources. We can copy the passwords and files and launch the binary. And turns out that everything that we did at the previous stage will not go to the final container. This final container will be very compact, containing the core, and you will not be able to inspect any files. You will not be able to access it. Well, in the previous case, we could, eavesdrop on the environment variables, but in this case, you can't do it. So we can compile the application using C join enable 0, so that the C-level libraries get to this container. What else can we have in these containers? This story works when we vendor the code, but what if we have GoProxy? We have to download the files every time, and the module will not have an easy life, so to speak. So we can add another stage, which will be very basic, 0 level, and in that stage we can store all the modules that we need. So we copy the modules GoMod and GoSum, then we launch the download of those modules, and until GoMod and GoSum stay the same, this is cached, and then we get to the same mode and container. No download will occur, and this stage will be downloaded from the cache, and the compilation will occur faster. Another story, we have to make a difference between the containers in which we compile the code and in which we run the code. Here we just copied the code, we didn't modify anything, we just compile it. We just compiled it, we launched no linters. The linters are great, but we cannot guarantee that the linters will not change our code and add some artifacts that we don't want to have there. So we create a separate image that we want to have for the testing purposes. We can add some basic image, or we can add the linters, we can push it to some Docker hub or to other registry, and we will have some basic image that will contain the linters and additional instruments that we may need, and we can use these instruments later on in a separate container that we only use for testing. Based on that, we create a different container, we copy our code there, we test, we launch linters, we don't do anything with this container, it doesn't go to production, if we don't have a toolchain for continuous integration. Oh, that's a very good way to be fairly independent. So what happens with the container when it's ready? The container is launched somewhere in some real environment. Of course, there may be different security issues that you may have. But when we launch containers, we are moving to the level of infrastructure, to the layer of infrastructure, and these are the issues that are handled by people who take care of the infrastructure. So, what do we get as a result? Okay, we have to do security checks, and DevOps culture teaches us to add security checks as soon as possible, literally at every step of the way. When we begin to write a code, when we begin to design it, when we start to test, when we try to launch it in the container, it is clear that you can also automate these checks. Linters help us do this and automate these checks. What other security instruments do we have? But unfortunately, it is not possible to automate everything. For example, working with dependencies is absolutely impossible to automate completely. And it is impossible to be completely confident about what's happening inside those dependencies. So there's a lot of manual work involved. You can't do anything about it, and it would be good for all of these manual actions to prepare a checklist that you could use during the code review. I know that with data you may have problems, and that you have to look at how you work with data. You may have problems with code. And when I make a review for my colleague, when I review my colleague's work, I may not remember what needs and what doesn't need to be done. But if I go along the checklist, I will never forget anything. And that's much more efficient. What else can be done? As I said, if proxies don't have any additional functionality, there are some big manual things to do with dependency. It would be great to contribute something to the Go community. And if you think about what can be contributed to the Go community, then security is probably the field in which you can play. For example, how can you simplify your work with dependencies? How can you launch linters to audit the dependencies? These things do help, but they do not cover the entire field of security issues and challenges. And that's the area where you can contribute, when we can make a difference. Thank you very much. The slides and additional materials are available in that link, and I'm ready to answer your questions. Thank you. Elena, thank you very much for your presentation. A lot of useful information. I have 3 questions, if I may. My first question is about sensitive information inside the code. I know that the methods for processing entropy of codes in order to prevent kind of password sniffing. Are there any linters that are available? Can you please repeat your question, because I couldn't hear it well enough? Sensitive information inside the source code. I know that you can measure the entropy of the code when you commit the code, and you can identify the possibility for the brute force of the password. I know that these linters are available for Go. They are perhaps on the blind side, on the list of blind side linters. Perhaps they are out there, but I don't know. I never store passwords inside the code, but perhaps they exist. Specifically for Go. Perhaps GoSec performs this. My second question is this. Perhaps sometime you need to guarantee the absence of passwords in the memory. We know that in Go we have garbage collectors. Do you have any other ways than CGO that can guarantee that no sensitive information is stored in the memory? Perhaps that's one of the story that when stored about not storing sensitive information in environment variables, but also inside memory. I haven't heard about any specific utilities that can help you do that, but you can look at configs manually. You can review your code, and you can declare the variables in such a way that they never are stored in memory. But I don't recall any utility or service that could do that for you. Any other questions? Thanks very much for the presentation. I'd like to go back to the beginning of your presentation. There was an example when there is an attacker that got access to the code, to the expector. Yes, you can use the Vault, but so that for the container to access Vault, it needs to have some token. So how do you give the key to the container so that the host doesn't lose any information? Thank you for the question.
Thank you for your question, but as a rule, we only need token once when the app is loaded. And so therefore, we can generate a one-time token when launching the application and then make this token inaccessible. Yes, it can be seen in the environment variable, but you won't be able to do anything with it. Next question here. Elena, my question. In your talk, you mentioned GopherCon, but never mentioned vendoring, the vendor folder that allows doing the same thing without Google Proxy. Yes, thank you for the question. Actually, before GopherCon came up, we just did vendoring. We put all dependencies in the code, and I still do it. I like it more than GopherCon, because only in the case that we're vendoring, we perfectly know what exactly our code is working with, what we have. So in this respect, yes, I'm a bit of an old-timer, so I always keep everything as part of the vendor. I recently managed to launch Artifactor. Looks like Go Center, but only for our internal dependencies. But yes, I do prefer vendoring. Hi. I attended the Thursday Go meetup, and they told us a lot about this, including the attacks. I learned that it is done in my company, but on the JavaScript side. So whose responsibility you believe it is? Thank you for the question. Actually, in the code that I usually see, these checks are done on both sides, for the simple reason that if we have a client app application calling the server, nothing stands in the way for the client to be spoofed, so that some bad things may be sent over to the server. So validation both sides is a good idea. What's your experience? From your experience, what's the moment, what's the point in time where teams have to start thinking about allocating resources for this? Because when you're starting a project, especially a small one, it's very difficult to allocate resources. That strongly depends on the company that you're working at or the projects that you run. I have said that I work in a bank now, and so we have the security team that makes all the necessary steps, helping developer teams do what they must. But what I learned from them is that a developer can also be made responsible for security. And as I showed in the first slide, whichever stage we are at, we can always add some security aspects. What can help? You can find a person within your team that is interested in security, and maybe ask him or her to learn something new about security. So he's becoming what we call security champion, responsible for the person responsible for security within the team. They can additionally check what we have designed earlier in terms of meeting the security requirements. So basically it would be, rather than being a person from the outside, that would be a member of the team. But yes, on the whole, even if you read some standard books about DevOps, security is mentioned there, and quite often it is explained how to introduce security in the standard DevOps process, what to do at which particular point. But on the whole, I think the whole problem is about the number of resources, and if the project is small, it's very difficult to find a person to do this job. I agree with you. Well, thank you. Thanks for your talk. It's become quite popular recently to attack in a way that you take some popular account, then you buy it or you steal it, and then inject something and keep it dormant until it can be exploited. Are there any tools to fight that? Well, Go as such, apart from storing versions in the library, we also store a hash. It's either a hash of the tag that you've downloaded or the module hash. If we do use these things, then once somebody tries to download a version with a different hash, we'll get information that the hash did not meet and maybe something wrong with the library. Another problem is that quite often we're writing microservices, and let's say in 5 microservices we were absolutely sure that everything is fine. Then we start another laptop where the dependencies have not yet been downloaded, and then oops, we get something wrong. So it's very important to check not only a hash of a single repository, but also to check the different microservices using the same hash dependencies. Or maybe somebody use monorep, and if it does work, it's okay. Actually, Proxy will help us in that respect, because if we've downloaded some dependency once, we know it's going to be immutable, and in this version of the module, it'll always be this, it'll always be there, and everything will always be safe and secure. Any more questions? If there are any more questions, Elena, I'm here. To your left. Okay, I've got the floodlight here, so I can't see you. All right, my question is, so imagine you have a server running in Docker. The configs of database connection, other servers, where is it all stored and how is it secured? Thank you. Thank you. That depends on what config files. And again, if it's about some passwords or some private keys, we keep it all in the vault or some similar tool that the cloud provider offers us. If these configs are not sensitive, for instance, they keep some URL, but not a big problem if somebody sees it, you can store it in a console or in environment variables or somewhere else. The important thing is that what sensitive information you have, to protect it as much as you can. Thank you. That was the last question. Elena, choose the best one. I choose the question about security practices in teams in row 4, I think. Thank you.